All right, welcome to part two of this exam 3. So we're going to start with question 11. Which of the following statements best represents the notion of a theoretical probability? On a multiple choice test, each question has 7 possible answers. If you make a random guess on the first question, what is the probability that it's correct? That's theoretical because you have an equal chance of grabbing each option and you don't know which one you're grabbing. So that definitely works. Let's look at the other ones just to make sure we are correct. But I think that that one looks pretty good. Of the last 100 people who failed the lie detector test, 23 turned out to be telling the truth. What is the probability that the next person who fails the test is actually telling the truth? Now, this is not theoretical because you don't know the next person coming in. You can't rely on previous detections to see if they're, there's no equal probability among each of the events. Meaning the next person comes in, because the past 23 failed because they were lying, doesn't necessarily tell me that the next one will. So that one doesn't work, so I can cross that off. Every week, Joe plays chess with his father. Of the last 50 games, Joe has won 55% of the games. What is the probability that Joe will win the next game? Once again, on this one, the events are not independent. I can't project that the next game will be one in which Joe, because there's a lot of factors to chess. You can't just say, if we knew for sure that Joe always played the same and always won with the same probability, then that would be one thing, but we don't. It may be just a feeling I'm having, but it sure likes that there's a low probability I'm going to get a passing score on my next math exam. Once again, we don't, each event is not independent and equally likely. So actually, letter A is the best choice on that one. Okay, let's move on. 12. On a multiple choice test, each question has 4 possible answers. If you make a random guess on the first question, what's the probability that you're correct? Okay, so remember, probability is the number of ways I can do it, and that I get correct. There's only one correct answer, and there's 4 choices I have. So 1/4, so C is the correct answer, and we move on. 178 people who came into a blood bank gave blood. 394 had high blood pressure. Use empirical method to estimate the probability of the next person. So because we have large numbers, that's the empirical method, so I can do a reasonable guess. So on this was question 12 and question 13. So my reasonable guess would be the following. Usually those who come in, 394 out of 1768 got high blood pressure, and so most likely, if it follows the same empirical method style, we'll have that, so I can just do that calculation. And so it's about roughly 22%, okay, or 0.22 is the likelihood that the next person will have a high blood pressure. All right, let's read the next question, number 14. A bag consists of 6 marbles, 3 blue, and 1 green marble. After shaking them thoroughly, you randomly select 2 marbles from the bag without replacement. What's the probability of selecting 2 red marbles? Okay, so the probability that the first one I select is red is, well, there's 6 options, and 6 plus 3 plus 1 is 10. Now remember, because we're doing 2 events, we then multiply that with the second event. In this case, we're now going to draw a second red marble. However, there's only 5 red marbles left in there, because remember, I drew one of the reds on the first option. And there are only now 9 marbles in the bag for that second draw. So the first one had 6 red marbles out of 10. The second option would have 5 red marbles out of 9 options, and that will give me my probability. And actually, I can actually go 5 goes into 10 2 times, 3 goes into 6 2 times, and 3 goes into 9 3 times. 2 goes into 2, so I'm left with 1/3, or 1/3 probability. So A is the correct answer. Oh, I'm sorry. I did, that was 15, I was about to read it. So 0.33, which is actually the same, okay? So ignore that right there. It might be the correct answer, but we'll have to wait and see. Let's do this. What's the probability of not rolling a number larger? Actually, I can probably click on this and delete it, so that way we can, there we go. Okay. What's the probability of not rolling a large number than 4 with a fair dice? Okay. So for this one, it gets a little bit tricky, but what we're looking for is the probability of rolling a number Okay, we want to know the probability of not rolling a number larger than 4. Okay. Well, if we know this one, the probability of rolling a number greater than 4, we can take 1 and subtract that to find the probability of not rolling it. So let's find this one first because it's a little easier. Because what I can do is, how many options are there? Well, I can roll a 5 and a 6. Any other number, so I have 2 options out of 6 or 1/3. So that's the probability of rolling a number greater than 4, larger than 4. What's the probability of not doing that? Well, you can go 1 minus that 1/3, and it'll give you 2/3. You could have also done it this way. The probability of not rolling larger than 4 would be 1, 2, 3, and 4, which would have been 4 options out of 6, would also reduce down to 2/3. So either direction, in this case, wouldn't be too bad. But you always want to get into, so 2/3 is the correct answer. But I usually get into the habit of trying to find out which direction is the easiest one to go. Meaning, I only had to count 2 numbers on the last one. This one I had to count 4. Choose an assorted package of donuts at random. The probability is 0.35 that is chocolate and 0.2 that it is glazed. What is the probability that a randomly chosen donut is something other than a chocolate or a glazed? Okay, so remember we have 0.35 is chocolate, 0.2 is glazed, and if I was to add those up, 0.45 is other. Okay, so what's the probability that it's other? Well, there we go, we just answered it, 0.45. Because remember, they have to add up to 1. So that was our clue. So I put 0.35 plus 0.2 to get 0.55, and then I said 1 minus 0.55 was equal to 0.45. And so that's how I could figure out that answer. That was problem 16. Let's move on to 17. 12 jurors are selected from a pool of 20. Determine whether the events A and B are independent. A, the first person selected is a woman. B, the second person selected is also a woman. And so for this one, what you have to think about is just kind of look at the situation. Are they independent of each other? Well, since I pull out the first one and it's woman, and then I go back, it could change it. Okay, meaning if I was to select a juror and then put them back in and then reselect, then the probability would be the same. But this is not independent because of that reasoning. So I would say no. Because once I select the first person, the second, it's going to change the probability of the second person being chosen. Determine whether the events of A and B are independent. Event A, a couple's first child is a girl. Event B, the couple's second child is a girl. This one is yes, because really the probability doesn't change. So the first child is a girl. Just because it's a girl doesn't mean the second one will also be a girl. It's the same probability, 50-50 on each of those options. Technically, there's probably a lot more to that, but we don't have to get into that math right now. 19. The probability of correctly answering the first 3 questions of multiple choice if random guesses are made and each question has 6 possible answers. Well, the problem I get the first one correct is 1 out of 6. I'm sorry, so that was 18 we're doing? I'm sorry, 19. We're on 19 right now. So the probability of the first one is 1/6. The probability of the second option is also 1/6. And the probability of the third is also 1/6. And you multiply those 3 events together, and you get 1 over 6 times 6 times 6. 216. And so 1 divided by 216 will give us the probability. Since I don't see it as a fraction, it's a decimal. So I need to do the decimal calculation. 1 divided by 216, 0.0046, and B is the correct answer. What's the probability of selecting all women of a 7? So let's go to the next problem. We're on number 20. Last one for part 2. All women for a 7-person jury from a pool of 10 men and 10 women. So what we want to do is we're going to look at each of the probabilities of these, okay? So the first question you ask yourself, is this probability an and? Is this probably an either or at least once, if you remember back? So this is an and, so I'm going to just do multiplication across, okay? Are these dependent or independent is the next question, and this is dependent. Okay, so for that reason, we're going to have to remember, I want the probability of A and B, which if you remember was the probability of A, and then we're going to multiply it by the probability that B, I've run out of room here, let me just reword that down here, times the probability of B given A. Okay? And so now we can actually do this calculation. So, the probability of A happening, in this case, let's see, so we have 10 men, 10 women, so there's a total of 20. Okay, so the probability that selected woman is 10 out of 20. Okay, so that's the first one, P of A. Now we want to multiply the probability of B given A. Okay, so in this case now we want to keep selecting, so we now have 9 women to choose from out of 19. Then we have 8 women to choose from out of 18. Remember, we're choosing 7 and we want all women. Now we want 7 out of 17, 6 out of 16, 5 out of 15, and 4 out of 14. If I multiply those together, I will have my answer. So what I'm just going to do is go 10 times 9 times 8 times 7 times 6 times 5 times 4, and divide that by 20, divide that by 19, divide that by 18, divide that by 17, divide that by 16, divide that by 15, divide that by 14. So 0.00155. And there we go. A is the correct answer. And I'm done with part 2.